All right, welcome back everyone. Today, we are diving into something that can literally make or break your project's timeline. I'm talking about the Work Inspection Request, or as we all know it, the WIR. Look, if you're an MEP engineer on site, getting this right isn't just a nice-to-have, it's absolutely critical.
So, let me just ask you this straight up. Think about it. You've just finished a really complex installation. Maybe it's ductwork, maybe it's piping, could be electrical containment. You've put in the work. Now what's that one single piece of paper standing between you and getting that all-important sign-off?
Yep, you got it. A perfect work inspection request. And believe me, this isn't just about mindless paperwork or bureaucracy. A really well-done WIR, that's your golden ticket. It's how you dodge delays, how you prevent that soul-crushing rework, and how you prove without a doubt that your work meets every single quality standard.
Okay, so let's really break this down. We're going to build the perfect WIR together, step by step. And we'll start with the most basic question of all. Why is this one form so incredibly important? Why is it the absolute gateway to getting that approval from the consultant?
You know, you can think of the WIR as the central hub for everything. It connects all the critical pieces. It's your formal promise of quality and safety. It's your hard copy documented proof that you're following all the building codes. And you really can't afford to mess that part up. And hey, on a personal level, a track record of clean, professional WIRs, that builds your reputation on site faster than almost anything else. It really does.
All right, let's get practical. Time to roll up our sleeves. You need to understand that every single successful inspection, it doesn't start on site. No way. It starts way before that, right at your desk, with some really careful document preparation.
Think of this as your pre-flight checklist. First, you've got to have the approved IFC drawings. That's your treasure map, right? Then you need the approved material submittals, which prove you're using the right gear. And this is huge. You need the project's inspection and test plan, the ITP, plus all the relevant codes, whether it's the Saudi building codes or international ones like ASHRAE or NFPA.
Now, for anyone who's kind of new to this, let's just quickly define what an ITP is. The inspection and test plan, just think of it as the project's official playbook for quality. It tells you exactly what needs to be checked, when it needs to be checked, and who's supposed to check it for every single task. It's your #1 guide here.
Okay, so you've got all your documents lined up. Now it's time to actually fill out the WIR form. And this is the moment where all that prep work turns into an actual official request. And trust me, every single detail matters.
So, what do? First, you give it a unique WIR number and specify the discipline, like HVAC or plumbing. Then you have to get super specific. What's the activity and exactly where is it? We're talking grid lines, floor levels, everything. And crucially, you have to link to every relevant drawing number and the specific codes you're following.
Listen, I can't stress this enough. The details you put in here are basically your first line of defense. Don't just write something lazy like code compliant. No, specify which code. If it's a fire sprinkler system, you better be referencing NFPA 13. If it's ventilation, you're referencing ASHRAE 62.1. This tells the consultant, hey, I know what I'm doing. I've done my homework.
All right, the paperwork is looking good. Now we get to head out to the site for what I think is the most critical part, the on-site verification. This is where the rubber meets the road, where all your prep work gets tested against what's actually been built.
So you've got your checklist in hand and you're walking the site. You're checking everything. Are the duct dimensions a perfect match to the IFC drawings? Is the spacing between your pipe supports and hangers spot on? Is every single penetration through a wall or floor sealed with the right fire stopping? And what about testing? Has that pressure test been done and did it pass? These aren't suggestions, folks. They're non-negotiable.
And for stuff like drainage pipes, you literally have to prove that physics is on your side. This simple little formula for pipe slope, that's your proof that water is actually going to flow downhill. It seems like such a small thing, right? But getting this wrong means an instant failed inspection and some really expensive rework. So the lesson is simple. Measure it, calculate it, and verify it. Every single time. Okay, so let's recap. You've done the prep at your desk, you've done the checks on site. Now for the final crucial step, you've got to compile all of this evidence into one professional package. You want to make it so good that approving it is the only logical choice for the consultant.
Remember, your submission is so much more than just the form itself. You've got to attach crystal clear site photos. That's your visual proof. You need to include all your test reports, like pressure tests for your pipes or leakage tests for ducts. Make sure you reference your completed ITP checklist, and then you package it all up and submit it through the official project channel. AconX, BIM 360, whatever you're using.
Theory is one thing, but let's make this real. How does all this come together out in the field? Let's walk through a real-world example, say for a standard HVAC duct installation.
Okay, check this out. We've got WIR HVAC 014. The engineer has ticked off everything. Duct size and gauge? Verified. Sealing at the joints? Confirmed. Hanger spacing? Let's see, 1.8 meters? Checked. Fire stopping at the wall penetration? Looks good. Leakage test report? It's attached. And look at this. They've referenced the specific codes, SPC 501, SMA-CNA, and NFPA. Now that is a solid, defensible WIR.
And hey, here's a final little tip to make your life on site just a bit easier. This table right here, think of it as your cheat sheet. Keep these simple checks and formulas handy. Seriously, whether you're trying to quickly calculate air leakage or just need to mark a pass or fail on a hanger check, having this in your back pocket is going to make your job faster and a whole lot more accurate.
So there you have it. That is the complete framework for absolutely nailing your work inspection requests. The steps are clear, right? From the prep work all the way to the final submission. So the only question left is, how are you going to take this and apply it to make sure your next site inspection gets that first-time pass?